Look at the three pictures of very diverse rocks in the images below. How are they different? How are they alike? Which Earth systems created these materials? What processes work to recycle the rock materials on Earth? Where does all the energy needed for these processes come from? Eroded basalt rock along a beach in Washington, folded metamorphic rock in an Arizona mountain, weathered sandstone arches in Utah. The black basalt along the beach is actually eroded lava flow from an ancient volcano. Basalt is classified as an igneous rock because it formed from molten magma. Gneiss rock was formed when buried rock layers were remelted and cooled, resulting in bands of minerals that are folded. Gneiss is classified as a metamorphic rock because existing rock was changed due to tremendous underground heat and pressure. Sandstone, a type of sedimentary rock, was formed from sediments collected at the bottom of ancient rivers or seas that were buried and became solidified. Later, the area was uplifted, exposing the sandstone, which was eroded repeatedly by winds that sculpted the formation into the arches and openings you see today. The story of these three rock types is the story of our Earth and the constant recycling of materials above and below its surface through the interaction of four major systems on Earth: the geosphere, rocky lithosphere, the atmosphere, air, the hydrosphere, water and ice, and the biosphere, living things. All of Earth? As processes are the result of energy flowing in matter cycling within and among the planet. As systems. This energy is derived from the sun and from Earth's hot interior. The energy that flows and matter that cycles produce chemical and physical changes in Earth's materials and living organisms. The rock cycle geologists classify rocks into three categories: sedimentary, igneous, and metamorphic. How do you think the three major rock types are formed? Rocks are separated into these three types based on how they were made. Sedimentary rocks come from the erosion, deposition, and cementation of sediments laid down at the bottom of bodies of water such as rivers, lake beds, or the ocean floor. Igneous rocks form from the melting and cooling, crystallization, of magma, lava, or other rocks that were melted deep within Earth. Metamorphic rocks are pre-existing rocks that have changed by heat and pressure. When rocks undergo additional processes, they can change from one type of rock to another. Depending on the processes, any type of rock can become any of the other types. It could even become a new rock of the same type. For example, a sedimentary rock could become a metamorphic rock, an igneous rock, or a new type of sedimentary rock. This depends on what happens to it. The processes by which rocks change into new rocks make up the rock cycle. Remember that energy from the sun and earth? As hot interior drives the processes in the rock cycle. Igneous rocks are formed when lava or magma cools and solidifies. This solidification is known as crystallization. Molten rock under Earth? As surface is called magma. When magma reaches the surface, it is called lava. Igneous rocks have interlocking mineral crystals that vary in size depending on how rapidly they cool. When magma cools slowly under Earth, as surface due to high temperatures, the mineral crystals grow very large. Igneous rocks that cool slowly under Earth, as surface, are known as intrusive igneous rocks. Intrusive igneous rocks, diorite, left, and granite, right. When lava cools on Earth, as surface, it solidifies very quickly, resulting in small crystals. Sometimes no crystals will form at all. In that case, the rock will have the characteristics of glass. One example is obsidian, shown below. A volcano may shoot blobs of lava into the air. These blobs have many air bubbles, like pumice, shown below. They cool so quickly that they solidify before they hit the ground. Lava that oozes out and cools can form a black rock called basalt, shown below. Igneous rocks that cool quickly on or above Earth's surface are known as extrusive igneous rocks. To remember this concept, think of external when considering extrusive igneous rocks. Extrusive igneous rocks form on Earth's surface. Extrusive igneous rocks, basalt, left, obsidian, middle, and pumice, right. Sedimentary rock formation. Where do you think all the sediments that form sedimentary rocks come from? Weathering. Rocks can be broken down by forces on Earth in a process called weathering. Once rocks are broken down, the smaller pieces are called sediments. The weathered pieces can be from anywhere you find rocks, such as mountains, plains, and valleys. Erosion. Sediments can be carried from place to place. This process is called erosion. Erosion carries sediments through wind, water, gravity, or other means. For example, sediments can travel downstream in a river. They can also roll downhill in a landslide. Deposition. Eventually, sediments stop moving and settle into layers at the bottom of rivers, lakes, or oceans. This process is called deposition. Compaction and cementation. New layers of sediment build up slowly over time, pressing down on the layers below. Dissolved minerals, such as calcite and silica, cement the grains together. In time, compaction and cementation lead to the formation of a sedimentary rock, such as sandstone or conglomerate. These hills are made of sedimentary rock called sandstone. Sandstone was deposited underwater, one layer on top of another, and then compacted and cemented together. This area was eventually uplifted, and after many years, weathering and erosion have exposed the formations visible today. The rock cycle is continuous. Not all sedimentary rocks form from the pressure of compacting sediments. When minerals come out of a solution and settle on the ocean floor, a chemical sedimentary rock forms. Gypsum, on the left, is an example of a chemical sedimentary rock. Organic sedimentary rocks, such as limestone, on the right, form from the remains of living things. Gypsum, left, is a chemical sedimentary rock. Limestone, right, is an organic sedimentary rock. Metamorphic rocks. When rocks are buried deep in Earth's crust, heat and pressure can cause the buried rocks to change into new rocks called metamorphic rocks. Metamorphic rocks start out as some other kind of rock, such as sedimentary, igneous, and even other metamorphic rocks. Rocks get buried under the tremendous heat and pressure of the layers on top of them. This compacts and melts existing rocks. Heat and pressure can change the grain size and even the minerals that make up those rocks, producing new types of rocks in a process called metamorphism. One physical change, called foliation, is caused by extreme pressure applied to the rock from just one direction. This forms alternating bands of different colored crystals. Gneiss is an example of a foliated metamorphic rock that can be formed from banded sandstone. Metamorphic rocks are often characterized by bands or wavy layers of mineral crystals or by the presence of unusual minerals. Chemical changes can also occur during metamorphism. Under heat and pressure, mud that is compressed into shale, a sedimentary rock, changes into slate, a metamorphic rock.